In this example, we're asked to calculate the pH of a solution of NaOH with a concentration of 3.5 times 10 to the negative fifth molar. So we're going to go with our two steps again. Step 1, let's use the formula of the hydrogen ion concentration multiplied by the hydroxide ion concentration equals 1 times 10 to the negative 14th. Step 2, a little rearrangement as we always do. The H plus is going to be equal to 1 times 10 to the negative 14th divided by my hydroxide concentration of 3.5 times 10 to the negative fifth. And we solve the numbers and end up finding out that the hydrogen ion concentration is 2.86 times 10 to the negative 10th. Awesome, dudes. That's part 1 here. That's my first part of this one. Step number 2 is going to be to use the concentration in my pH formula. pH is the negative log of the H plus ion. So when we plug the number in, the pH is going to be equal to the negative log of 2.86 times 10 to the negative 10th. And our pH is going to have a value of 9.5. Once again, does that sound right? Yeah, it is. It's in the ballpark of that exponent. So my pH is 9.5. This is a basic solution. Alright, basic solution now. Anything over a pH of 7 would be considered a basic solution. Alright, dudes, let's try the next problem. In this problem, I'm throwing you a curveball. I want you to calculate the pH of a solution. Once again, I'm giving you the concentration of the base. But this time, the base has two hydroxide ions that are going to dissociate when it hits the water. So even though I give you the concentration of the base, you're going to need to double that to account for the doubling of the ions of hydroxide that will go into solution. Alright, dudes, same way as we always do. Let's use the concentration formula again. Let's plug in our values. H plus is going to be equal to 1 times 10 to the negative 14th divided by, in this case, check this out, dudes, you got to be really careful here. We're going to divide this by 2 times 4.5 times 10 to the negative 9th. And now I did that because there were two hydroxide ions. When we use that value, the hydrogen ion concentration in solution is 1.11 times 10 to the negative 6th. Awesome. That's part 1. We've gotten the concentration. That's essential for step 2. In step 2, we're using the pH formula. The pH equals the negative log of the H plus ion. Let's plug our values in, guys, and solve for the pH. And we end up finding the pH is going to be equal to 5.95. You know, once again, that's in the ballpark of my exponent right there, too. Alright, dudes. That's all the examples for tonight. I hope it was helpful. I hope it brought some clarity to this topic for you. Alright, man. Thanks a lot, guys, for tuning in. Have a good night. Peace.